Welcome to this explainer. Let's talk about a milestone literally every growing engineering team has to tackle at some point. I'm talking about moving away from those chaotic, manual infrastructure setups and reaching that highly secure, automated Terraform nirvana on AWS. We're going to dive right in and look at the actual best practices, the real-world strategies that separate fragile, hobbyist projects from rock-solid, production-grade architectures.
To kick things off, I want to ask you a rather provocative question. Think about it. Where is your Terraform state file right this second? Is it just chilling on your laptop? Or maybe it's checked into a Git repo somewhere? Because honestly, if it is, you're operating with a massive blind spot. Just one tiny misconfiguration or one lost state file, and you could wipe out your entire production environment, literally in the blink of an eye.
Okay, let's dive into this harsh reality for a second. Your Terraform state file, that's your absolute source of truth. It is exactly how Terraform knows what's actually running in the real world. So keeping it local is basically inviting disaster. First up, you've got data loss. If your hard drive crashes, boom, your infrastructure map is just gone. Then there's race conditions. If you and a teammate try to run updates at the exact same time, you are absolutely going to corrupt that file. And finally, and this is a big one, plain text secrets. A lot of Terraform resources store really sensitive stuff, like database passwords, completely unencrypted right there in the state file.
To fix all of this, we're going to follow a very specific blueprint today. First, securing the source of truth. Second, enforcing least privilege access. Third, building the three-tier architecture. And finally, automating the assembly line.
Part 1. Securing the source of truth and building a resilient state backend.
You really can't build a secure cloud architecture if you haven't locked down your blueprints first, right? So the very first concept we absolutely need to nail down is remote state locking. It's kind of like hanging a "Do Not Disturb" sign on your infrastructure. It's a mechanism that actively prevents concurrent write operations to your state file. So, if I'm applying a change and you try to apply a change at the exact same second, state locking steps in and forces you to wait. It's an absolute necessity if you're collaborating with a team to ensure nobody accidentally overwrites or corrupts the whole setup.
To pull this off safely on AWS, we need to ditch those local files entirely and transition over to shared remote backends. The gold standard in the industry for this is using Amazon S3. It gives you a highly durable encrypted storage spot for the state file itself. And then you pair that S3 bucket with an Amazon DynamoDB table. DynamoDB essentially acts as your traffic cop. It manages those state locks we just talked about and totally eliminates those nasty race conditions.
Now, when you set this up, there's a mandatory checklist you have to follow. It is not enough to just toss the file into S3 and walk away. You absolutely must enable AES 256 encryption at rest. That's what protects those plain text secrets. You have to block all public access, obviously. And so the crucial point here is you must turn on S3 versioning. Versioning is your ultimate failsafe. If someone accidentally deletes or completely mangles the state file, versioning means you can just hit undo, restore a previous known good snapshot, and recover almost instantly.
Moving on to Part 2, enforcing least privilege access. These are your guardrails. Let's shift our focus over to operational security. Now, what's really interesting here is the massive difference between the old way of doing things and the new way. The golden rule: broad access is a huge vulnerability. On the left side, we've got legacy IAM users relying on hard-coded, long-term access keys. These are incredibly high risk. If one of those keys gets leaked, an attacker has permanent access to your environment until you realize it and manually shut it down. Over on the right, we have the modern standard, IAM roles using dynamic credentials. These are super secure precisely because they're temporary. They just automatically expire after a short session.
And here's a peek at how that actually works under the hood. What you're seeing is an IAM trust policy that authorizes something called the assume role action. So instead of Terraform logging in with a permanent password, it essentially goes to AWS and says, "Hey, can I borrow these specific permissions for a bit?" AWS then hands over these short-lived credentials. Maybe they're only valid for an hour. It elevates those privileges strictly for the duration of that one single Terraform run, and the moment it's done, the keys just vanish.
Sticking to AWS best practices means you have to relentlessly apply this principle of least privilege. You really should never just grant admin access, shrug, and call it a day. You've got to continuously validate those IAM policies. The best way? Start with a completely empty policy and just iteratively add the exact services your Terraform script actually needs. Be proactive about it. Use tools like IAM Access Analyzer to hunt down and strip away any permissions that aren't actively being used.
All right, part 3, the three-tier architecture. This is where we build the fortress.
So we've got our secure state, we've got our secure identities. Now let's build the actual fortress. The absolute most robust way to design your AWS environment is by using a three-tier model. I really love using a castle analogy to explain this. Step 1 is the presentation tier. That's your application load balancer sitting out there in a public subnet. It's like the public gatehouse of your castle, facing the outside world. Step 2 is the application tier, which contains your EC2 instances inside a private subnet. Think of this as the private inner courtyard where all the real work is happening. And step 3 is the data tier, your RDS database tucked away in a totally isolated subnet. That right there is your heavily guarded vault.
Now, to make that castle analogy actually function, you need some really strict network isolation rules. As you can see, the presentation tier accepts your regular, everyday internet traffic on ports 80 and 443. But look closely at the application tier. It is configured to accept traffic only from the load balancer's security group. It literally doesn't even have a public IP address. And finally, the data tier accepts traffic only from the application tier's security group. Your database is completely invisible to the outside world. No internet access whatsoever.
This whole concept is known as security group chaining, and it is pretty much the ultimate defense in depth strategy. Why? It's all about controlling your blast radius. Let's imagine a worst-case scenario where your public load balancer gets compromised. Because you're using security group chaining, that attacker can't just make a lateral movement straight into your database. The blast radius is entirely contained within that very first tier. The database vault simply will not accept their connection.
Let's move to part 4, automating the assembly line and building the automated factory.
Okay, so we've got our secure physical structure built out. But here's the thing. If you have humans manually typing commands into a terminal to deploy infrastructure, mistakes are absolutely going to happen. It's just human nature. But bringing in a CI/CD pipeline, like GitHub Actions, replaces those manual commands entirely. And this brilliantly illustrates the new workflow. An engineer creates a feature branch, they open a pull request, and instantly, the pipeline kicks off an automated Terraform plan so the entire team can see exactly what's going to change before it happens. Once everyone approves it and it merges to main, the pipeline automatically runs Terraform apply. It is just a highly auditable, perfectly repeatable process every single time.
But you might be wondering, how exactly does GitHub securely talk to AWS to run that apply command? The answer is just-in-time access. Remember that whole least privilege principle we covered earlier? We are definitely not storing long-lived AWS secrets inside GitHub. No way. Instead, GitHub Actions uses the OIDC standard to basically trade a token for temporary AWS credentials, which means your pipeline is provisioning your entire infrastructure using absolutely zero long-lived secrets.
So I want to leave you with one final, slightly provocative thought to take away from this explainer today. Is your infrastructure genuinely built to survive an incident, or is it basically just sitting there waiting to cause one? Because when you combine a secure remote S3 state, strict least privilege IAM roles, a deeply defended three-tier architecture, and fully automated CI/CD pipelines, you don't just have cloud hosting anymore. You have transformed AWS into an automated, highly resilient fortress. Thank you so much for joining me today, and keep building securely.